Hello everyone. In this video we want to continue talking about the waves and properties of waves, how to know about the energy. And as you know, actually for all waves carry energy from one place to another. But actually some waves, they have the ability to carry more energy than other waves. Like example, I'll give you example. If a leaf falling on a water produce waves so small, but what about the earthquake? The earthquake اللي هو under the ocean can produce a huge wave that cause a great destruction, for example. Okay, let's now talk about the amplitude and energy, frequency and energy. I want you to look at this figure here. This one. For figure number 1, I'm going to talk about the first one, not this one. If I want to talk about the amplitude, you know the amplitude, which is this distance. I want to show you the amplitude. The distance between the crest and the rest point, or the trough and the rest point, right? So, if you look at first figure and figure number 2, this is figure number 2, which one it has greater amplitude, 1 or 2? As you see, 2 it has a greater amplitude. What does that mean? That means what? For greater amplitude, it means more energy it has. Yeah, for example, if the sound produce more amplitude or greater amplitude, it means the sound is gonna be higher, louder. You can hear the sound louder because it has more energy. For mechanical waves, I'm talking about mechanical waves, amplitude is related to the amount of energy the wave carries. Okay, again, the amplitude is related to the amount of energy the wave carries. For two similar waves here, as you see here, for these waves, the one with the greater amplitudes, which is 2, it carries more energy than number 1. Okay, so let's look now about number 2 here, this figure. I'm going to release this one. I want to talk about this figure here, with the one with the blue, green, yellow and red. Let's talk about the frequency. Actually, for frequency, greater frequency, more number of waves per second, which means what? A greater energy. It carries more energy. Okay, again, for amplitude, a greater amplitude, it means it has more energy. The same for frequency. More frequency, it means what? More energy. It carries more energy. I want you to look at this one in red, these waves, and waves in yellow. Where the wavelength is longer? The wavelength in here is longer than in yellow waves, right? Which one it has more waves? This one, 1, 2, 3, 4, 5, 6. Here it has way more longer wavelength, but it has what? Less waves, which means lower frequency. So here you have to look at this. Low frequency, which means low energy, which means longer wavelength. Look at the short wavelength. Look at here, the distance between this and this, shorter than the red, right? It means higher frequency and it means high energy. You have to put these in your mind. These are very important. Again, short wavelength, high frequency, high energy. Long wavelength, low frequency, low energy. Okay, for most electromagnetic waves, you remember we classified the waves into mechanical and electromagnetic waves, right? For electromagnetic waves, waves, energy is most strongly related to the frequency. For example, for high frequency electromagnetic wave like the X-ray and the gamma rays, because they have high frequency, very high frequency. That means they have very high energy. They have the ability to damage human tissues. like the X-rays, like the gamma rays. But what about the low frequency of electromagnetic waves, like the visible light and the radio waves? Actually, they have low energy, and at the same time, they can be absorbed by the human body safely without any damaging for the body or body tissues. Okay, so you have to put these points are very important. You have to put them in your mind. I want you to highlight this in your book. Just hold on. Let's look at this one here. Highlight with me all of these. All of these are important. Actually, here for mechanical waves, amplitude is related to the amount of energy the wave carries. For two similar wavelengths, the wave with the greater amplitude carries what more energy. Okay, like for example, here they give you example. You have to know the example. Okay, greater frequency can also mean what greater energy in a given amount of time. If wave for example here, for most electromagnetic waves, energy is most strongly related to frequency. Very high frequency electromagnetic waves such as your X-ray and gamma rays carry enough energy to damage human tissue, as I mentioned. Low frequency electromagnetic waves like the light waves or visible light absorbed safely by your body. Okay, it can't cause any damaging. Now let's talk about energy loss due to spreading. Actually, if you want to, for example, to put a stone or to if the stone fall on the water, the energy will be what? Will be spread on all direction, right, in the water. So actually when we talk about the waves moving, actually we talked about how they are moving, as in this figure here we have mentioned, as they are moving in a straight line, right, as you see in these waves. But waves usually spread in more than one dimension. A crest can be drawn as a shape such as a circle or spheres, called wave front. To understand what is the wave front, I want you to look at this video, listen to this video, and write notes while you are watching.
A wave's energy spreads out over time. Think of a sound wave. The sound is loudest close to the source of the sound and gets quieter farther away from the source. The same is true of the waves caused by an earthquake. The farther you are away from the center of an earthquake, the weaker it feels. Click the seek bar below the video. A wave front is all of the points reached by a wave at a certain time. The wave front covers less space near the source of the wave. Thus, the energy of the wave is distributed over a smaller area near the source.
So here you have to look near the source, the energy waves distributed, and they will go away and farther after that. Look at this.
Watch the wavefront here. The wavefront gets larger over time. As the wavefront gets bigger, the energy is spread out over a larger area. Eventually, the waves die out because the amount of energy at any one point is too small to be detected.
So I want you to put in your mind now, so for wave front moves farther from the source, the energy is spread over a greater area. Less energy is available at any one point on the wave front. If you measure a wave at a point farther from the source, you measure less energy. But at the end, the total energy of the wave front stays the same. Okay, so this is all about the energy and the waves and the amplitude and wavefront. If you have any question about them, you can send me your question. This is all for today. Thank you for listening.